Hello, my name is Casey Shibler and I'm doing a reassessment video on the magnetic field standard. I have chosen the following problem 54. It says, in the region shown in the figure right here, the magnitude of the horizontal component of the Earth's magnetic field is about 2 times 10 to the negative fifth tera. Originally, a compass placed at a location A points north, then a bar magnet is placed at the location shown in the diagram, which its center is 16 centimeters from location A. With the magnet present, the compass needle points 60 degrees west of north. So if we go on A, which pole of the magnet is nearer to location A? Well, what I deduced is we know that for a magnet, the field is going to travel north to south every time. So what is going to draw the needle of the compass towards the west? The south pole being closest will actually draw that needle in a 60-degree angle. So therefore, I put that the south pole is closest to the compass on point A. Then we go to part B, which says, what are the directions of the magnetic field at locations B, C, and D? Well, if we move on down here, due to this magnetic field shown like so, you can say that here's our 60-degree angle from our compass. This will clearly make B or D go north. This going up like that will deflect the compass needle to the west again. And then B, since as you can see it's going around like that, will cause the magnetic field to deflect a little towards the east for location B. Then we move on to part C. It says, what is the magnetic dipole moment of the bar magnet? Now, this took me a hot minute, and I hope that it's right. But I have confidence that it's right because I don't know of any other way to do this. It's the only way that I could conclude. So, I know the magnetic field of the dipole is equal to mu naught over 4 pi 2 times the magnetic dipole moment over r cubed. So I know the magnetic field of the Earth, that's what they've given me. I know mu naught over 4 pi is equal to 1 times 10 to the negative 7, so I don't keep having to write that out. And I know r is 16 centimeters, 0.16, as shown here, and as I showed up here from A. And I do not know the magnetic field of the dipole, and I do not know the magnetic dipole moment, or that constant. So what I wanted to do first is solve for the magnetic field of the dipole. So since for point A they gave me the compass deflection, I can actually use that equation to solve for the magnetic field of the dipole because I also have the magnetic field of the Earth that they gave me. So once I plug this in, I can solve for BD, which gives me 3.464101615 times 10 to the negative fifth t. I just went ahead and stopped at 6 just because I don't want to plug in all those numbers. So then, now that I have the B dipole, now all I have left is solving for the magnetic dipole moment. So I go ahead and bring this equation down and I plug in my values. Here's my magnetic field for my dipole, my mu naught over 4 pi, and then I have my 2 times mobility and my r cubed, which is my 16 centimeters, which I converted to meters. I then rearrange this divided by this, bring down that 2, the 16 is going to go on top, which I'll multiply times my magnetic field of the dipole, and that gives me mu is equal to 0.70868 amps times meter squared. And this concludes my video. Thank you so very much.